In the previous video, we looked at how file upload vulnerabilities or file upload attacks can be conducted by giving you a very narrow and specific example. So file uploads, and in this video, we're actually going to look at protecting against file upload attacks. These represent an easy way for an attacker to inject malicious code into your application, and much more than that. You need to ensure uploaded files are kept at arm's length until they are fully secure, or else risk creating an easy route having your system compromised. Now, prevalence is really common, and I can validate this because I see a lot of file upload issues in most of the application security tests that I'm conducting. The exploitability is moderate, so it's not easy, and the impact is quite significant. Sophisticated hackers typically exploit a combination of vulnerabilities when attacking your site. So in this situation, upload malicious code to a server is one step of the entire chain of attacks. The next step is finding a way to execute the malicious code. Even big companies fall fool to this vulnerability, particularly if they are running complex legacy code base. Now, any input coming from a user ought to be treated with suspicion until it has been guaranteed to be safe. This is very true for uploaded files because your application will typically treat them as a big blob of data at first, allowing an attacker to smuggle any kind of malicious code. So segregate your uploads. This is one way to actually protect against this vulnerability. So they are intended to be inert. Unless you're building a very particular type of website, you're typically expecting images, videos, or documents rather than executable code. So this is the usual input that is expected from users. If this is the case, you should be making sure that uploaded files are kept separate from application code. That's why a lot of companies resort to uploading in certain buckets with very limited permissions. Consider using a cloud-based storage, as I was just saying, or a content management system, CDN, for example, content delivery network to store uploaded files. Alternatively, if you're sure of your ability to scale your backend, you could write uploaded files to your own local stuff. Both of these approaches prevent accidental execution of an executable file. Well, execution maybe, but not necessarily dig into other vulnerabilities that might ensue by following this attack vector. Even storing uploaded files on a remote file server or in a separate disk partition helps by isolating the potential damage a malicious file can do. Now, another way to protect against this, ensure upload files cannot be executed. That's why if your uploaded files are designed to be images or maybe static content, images, videos, whatever, they are written in such a way that the operating system knows not to treat them as executable code. One way to do this is to make sure that content type is set. Your web server process should have read and write permissions on the directories used to store upload content, but you should not be able to execute any files there. So web server can read and write, but cannot execute. If you're using a Unix-based operating system, you should make sure that it is -X in the file permissions. Rename files on upload. This is a very good practice. You, instead of uploading the files with the same name that they have been given or that they come from the uploader, you should just rename them, and you should rename them in a non-guessable way using some sort of a key or something. Upload files are generally made available back over HTTP. What's the point of uploading an image if it isn't available anywhere on your website? So implement a method of indirection when serving the upload content back in the browser so that content is not referenced by its name from the original upload. A lot of issues that could come from here. Validate file formats and extensions by content type, of course. You can also make short file extensions of uploaded files against a whitelist of permitted file types. So oftentimes application security professionals are able to bypass this because oftentimes developers just implement restrictions browser level. So you can easily determine as an application security tester, you can easily determine this. So if the browser, if you're trying to upload an exe file, for example, if you're trying to upload exe, the browser is gonna say not allowed, or extension not allowed. But if you're smart and if you've intercepted that request and you actually replay the request using a proxy or using just a browser with different extensions, you can more often than not, bypass browser restrictions by actually modifying your request. And I've actually seen this in in a few assessments as of recent. Validate file formats and extensions. Validate the content type header. This is really important, and it actually goes hand in hand with format and extensions. File uploads will be accompanied by a content type. It often is that requests are multi-part form data, and content type header should the supply type should belong to a whitelisted list of permitted file types, which again goes hand in hand with the previous protection. Be aware that simple scripts or proxies can spoof the file type, though, so this protection, while useful, it is not enough to actually dissuade a sophisticated attacker. Use a virus scanner. Virus scanners are very adept at spotting malicious files masquerading, so you can actually implement sort of an extension or an additional check to the uploads. Or if you're working with the cloud provider for your uploads, you can actually use some of their own solutions to this by running virus scanning against uploads. Might be a little bit tedious to implement, but it's worth checking. Other considerations: check file sizes, of course, because it's a good way to protect against denial of service. You can also sanitize the file names, of course. I've been able to actually exploit directory listing via, not directory listing, but a local file inclusion via unsanitized file names. But in this situation, they're saying that you could use it to exploit buffer overflow vulnerabilities. Regardless, it is a good practice to ensure file names can be sanitized before being written on disk, and also be careful with compressed files, because like for example, a zip bomb is crafted so that unpacking it will take up a large amount of time, disk space, memory, and this could actually cause unwanted unavailability to your application. So this is advice for defenders, but it is at the same time good advice for application security testers or red teamers when it comes to application security, because this actually gives a lot of insight into the attack vectors that can be implemented when actually trying to exploit local file inclusion. Now, further reading an introduction to web shells, unrestricted file upload vulnerabilities. I would actually look into this one, unrestricted file upload, which is of course from the amazing OWASP. So make sure to deep dive into this one. Now let's actually test ourselves. We've been recording for close to 10 minutes. Why is it important that uploaded files are not saved as executable programs? Executable files take up more room and can quickly eat up your server disk space. Which of the following methods is a good way of preventing file upload vulnerabilities? Running a virus scanner, of course, deleting files, Not necessarily. In some situations, this might actually be a solution. Making sure uploaded files are saved without the executable permission. This one is also true. This one is also true. Obfuscating the path to files kept on the server. This one's also true. So let's go to the lengthier, with the lengthier one. Alright, now, other vulnerabilities. Next one is going to be broken access control. So I'm actually really excited about that one too. So stay tuned.